Hello, so this is Anti-Relativity Lesson 3, Axioms of Special Relativity. There are lessons in special relativity. Uh, the aim here is to try to counteract that and give lessons in anti-relativity. And the way to do that is to point out what is being taught in relativity lessons is nonsense. Over the years, the teaching of special relativity has been to pile on more nonsense. So they're going to contrast how the teaching has changed. Taking an example, what was said in 1982 by Relativity Put, that was later said in 1991 when the book was updated. So this is the book, and so I'm comparing the two versions of the book, the one in 1982 with the updated version in 1991. And so mainly going with the second edition of the book and pointing out when it was different to the first edition. So the aim of this is to show that the methodology of teaching relativity is to move the goalposts. Some nonsense is said, but that is never enough, and some extra nonsense then gets added later. So the idea of moving the goalpost is really supposed to be a fallacy in logic, and people sort of sometimes argue you can't apply that reasoning to a theory. A theory, some people say, can be updated, but actually, when you're updating a theory, that's really just another form of moving goalposts, and so should ideally be thought of as a sort of fallacy, especially when you're not making it clear when a theory is being updated. So first off, Windler is going to talk about two axioms of special relativity, but going by Wikipedia, it talks of two postulates. Nothing is said about the postulates being different to axioms, so just going to have to assume here for the sake of argument that they're the same thing. You could actually start nitpicking here, but I'm not going to. Just going to pass on this issue. So now diving straight into edition 2, chapter 1, section 4, it says about Einstein's two axioms for special relativity, which presumably means two postulates. And it's referring to what we said earlier. As you've seen, Einstein's reaction to the failure of all attempts to detect the ether frame was radical. And I pointed out in another anti-relativity lesson the relativity text claiming this was talking nonsense. And so the book says, from Windler, he advances an axiom, which is Einstein, the following principle of relativity, that the laws of physics are identical in all inertial frames, or equivalently, the outcome of any physical experiment is the same when performed with identical initial conditions relative to any inertial frame. And in my view, that is a vague statement, but we shall pass for that for the moment. And the book carries on to say, strictly speaking, we should read inertial coordinate system for inertial frame. So when they talk about inertial frame, really that is abbreviation of saying inertial coordinate system. Since orthogonal axes can be set up with origin at any point and with axes in any direction, and since the 0 point of time can be chosen arbitrarily, the relativity principle, as applied to various coordinate systems within a single inertial frame, immediately leads to the spatial homogeneity and isotropy, and to the temporal homogeneity of each inertial frame for the performance of any physical experiment. And that's quite a mouthful, but it's not in edition 1. And why leads to the spatial homogeneity, etc., is not explained how. So it's making this statement. It's not really going into sufficient detail to explain what any of that means. The book carries on and says, note that Einstein's principle is a generalization to the Hall of Physics of relativity principle long known to be satisfied by Newtonian mechanics. Such a generalization is strongly supported by the essential unity of physics, for it would be very disturbing if, for example, the electromagnetic laws governing the behavior of matter on the atomic scale did not share in this very profound and remarkable invariance property of the laws of mechanics, which govern the behavior of matter on the macroscopic scale. And it's saying things like strongly supported, etc., and not explaining how again. So it's making big claims and not explaining how those claims are supposed to be supported. The book carries on and says, and indeed Einstein cited instances of manifest relativity from electromagnetism. Now, the first edition of the book words it slightly differently. It says, Einstein also cited instances of manifest relativity from electromagnetism. Edition 2 of the book carries on, for example, the current induced in the conductor by a magnet is the same whether the conductor is at rest and the magnet moving or vice versa. And that's also in edition 1. Edition 2 carries on and says, but of course the chief recommendation for this, as for any other axiom, is the success of the theory resulting from it. And that's not set in edition 1. So edition 2 now introducing the criterion for which for when should accept an axiom. Ideally should explain in more detail how that criterion is supposedly met, but as per usual, relevant details on important issues, stroke claims, are omitted. So you can see why these books are talking nonsense. Edition 1 has the following, and this is not in edition 2. And it says, over a priori arguments can be adduced to satisfy the adoption of Einstein's relativity principle, but in our present development it is in effect already implicit in the homogeneity and isotropy axioms for inertial frames. Where's that coming from? It's not. It's making up extra axioms which Einstein never mentioned, so it's need to look at it in more detail what's going on. It's when it's saying that Einstein has two axioms, which are usually said to be postulates, and now suddenly it's bringing in extra axioms stroke postulates. So edition 1 has footnotes not in edition 2, and it's citing these two sources, and it's got Dixon, who's written a book in 1978, and Ridler, who's written another book in 1977 about relativity. Edition 1 carries on, over other a priori arguments can be adduced to satisfy the adoption of Einstein's relativity principle, but in our present development it is in fact already implicit in the homogeneity and isotropy axioms for inertial frames. And it wants us to refer to this book by Dixon. So this is the book by Dixon. So this is the relevant paragraph which is being referred to, and we're going to have to look at it in more detail. So Dixon is saying This is the principle of special relativity. The laws of physics are identical in all inertial frames of reference. Now, that's what Dixon says, but Rindler doesn't say that. He doesn't use the phrase principle of special relativity. He uses instead the phrase principle of relativity, which I'm quoting here. Einstein, advanced as an axiom the following principle of relativity. So Rindler is talking about principle of relativity, and Dixon is talking about special uh, relativity principle. So they're not making it clear whether it's supposed to be the same thing or something different. This is the type of nonsense these books write. So we immediately plunge into ambiguity. Is the principle of special relativity the same as principle of relativity, or is it supposed to be two different things? And texts on relativity typically create obfuscation like this. If try to refer from one relativity text to another relativity text about some issue that want clarification on, find the opposite happening. Instead of clarification comes more obfuscation. One dissident, Harry Ricker, refers to this property of relativity text as them being irksome. There's no clear writing on relativity text making the issues clear. Anyway, putting aside that issue, Dixon continues, let us pause here to consider the nature of the assumptions that were needed to make this deduction. Essentially, it has been assumed that there is no qualitative difference between different inertial frames, and it has been deduced that there is no quantitative difference. And so, to my mind, that's just introducing extra assumptions. We got some assumptions here being stated, and some of them are being vaguely stated. In relativity text, it is never made clear how many arbitrary assumptions can be added ad hoc, i.e., they're all just a mess, these relativity texts. Next, Dixon carries on to illustrate this from the preceding section. Unfortunately, we're not used to going to that, but it's still more ambiguity when you get to that. If it had been assumed that all inertial frames are quantitatively identical, the functions f and g, and that's of 5.4 and 5.7, could have been taken to be the same, but instead the a priori possibility of their differing was accepted, and it was deduced from 5.22 that they are actually equal, provided only that beta equals 1. And so, unfortunately, Dixon is referring to things he did before this paragraph, page 23, things that have not been dealt with by the Rinder text. So, Rinder is referring to this book by Dixon, and that's the relevant bit you're supposed to look at, but you can't look at it really without the full context or all the other things being said, and it's just a mess. So, in order to make sense of Dixon, have to study him in great more detail than just page 23. This is, of course, going down the rabbit hole, where get continually diverted onto other issues, and we'll find it hard to get back to the render text. It seems to be a tactic of a relativist. If someone asks too many awkward questions, then they try to throw them down the rabbit hole and send them on diversions that ideally can never come back from. So anyway, carry on with Dixon. He says, if the Michelson-Morley experiment is accepted as evidence for the impossibility of an experimental determination of a state of absolute rest, then one is led to conclude that the laws of physics have the same qualitative form in all inertial frames. And my comment here is the relevant word here is if. If don't accept that, then have an absolute rest, presumably. He's not making that clear. By using the word if, it makes it sound optional as to whether they want to accept the impossibility of absolute rest or not. And of course, from my point of view, can accept absolute rest as being possible. But presumably these relativity texts are not really asking for that possibility. But this Dixon is using the word if, and it's making it sound that that possibility is viable. Dixon carries on, but at first sight it is possible say that the actual numerical constants that occur in these laws differ from frame to frame. The above deduction of the principle of special relativity shows that in fact this is not possible. Qualitative equality implies quantitative equality. What above deductions? I asked what? By the use of the word if, I saw it as optional whether to accept those deductions, and I opted for not accepting them. So nothing definitive was proven straight shown in the above deductions. So now back to Rindler, edition 1. Other a priori arguments can be adduced to justify the adoption of Einstein's relativity principle, but in our present development it is in fact already implicit in the homogeneity and isotropy axioms for inertial frames. And my comment is this claim was never shown. It may be why Rindler omits making the claim in edition 2. He may have realised it was invalid and omitted it in his revision. This is the typical mess they make. Edition 1, the demonstration of this depends on the simple lemma that between any two inertial frames, S and S prime, there exists an inertial frame, S double prime, relative to which S and S prime have equal and opposite velocities. And for this he cites himself in another text, in another book he's written, and it seems to have been updated as well. So, but rather than go further down the rabbit hole and look into him and citing himself, what he says next, he mentions proof. So offering proof of his claim is just being made. Edition 1, he says, for proof, consider a one-parameter family of inertial frames moving collinearly with S and S prime, the parameter being the velocity relative to S. And he says proof. This is edition 1. He says it's then obvious from continuity that there must be one member of the family with the required property, and he's referring to this figure 2, which I'm showing here, and that's not in edition 2. He says now imagine two intrinsically identical experiments, E and E prime, being performed in S and S prime respectively. We can transform E prime by a spatial translation and rotation and a temporary translation in S prime into a position where it differs from E only by 180-degree rotation in S double prime. Thus, by the assumed homogeneity and isotropy of S prime and S double prime, the outcome of E and E prime must be the same, which establishes Einstein's principle in the form of our second formulation. So he says assumed homogeneity and isotropy, so in order to get the proof has to add more assumptions. And I'm pointing out again that Einstein is not saying he's using more than these two postulates. So we're treating these two postulates as assumptions. Suddenly, Rindler wants to add a lot more assumptions. So really, it's not a very good proof. Hence, why, given the possible reason why, Rindler omits it from his revised edition too. So back to what Rindler says in both edition 2 and edition 1. He says the acceptance of the relativity principle, uh, Einstein's first axiom, seems harmless enough until we come to the second axiom. There exists an inertial frame in which light signals in vacuum always travel rectilinearly at constant speed c in all directions independently of the motion of the source, and the value of c is 2.99 so forth times 10 to the power 8 meters per second. But C can be treated as a good approximation as 3 times 10 to the power 8 meters per second. And that's good enough for many applications, he's saying. So it's nice for the text to say the principle of relativity seems harmless enough. It does need clarification to make it clearer what is meant, but in both this text and others like it, we don't get that clarification. And in the adding of the second axiom, things do turn into a big mess. So, first of all, this comment by Rindler. Second axiom, there exists an inertial frame in which light signals in vacuum always travel rectilinearly at constant speed c in all directions independently of the motion of the source. And so I take that to mean there exists an inertial frame. That could mean there's only one inertial frame that has the property for light speed c. But usually it's taken to mean all inertial frames have this property. It thus could start arguing of how to interpret that statement. It's not a very clearly written statement, it's just vague. Ideally want something much more clearly expressed and with some mathematics. So, next. Rindler says, by itself, this axiom is also perfectly reasonable. And I disagree. As I pointed out, it was unclear what was meant by it. He wrote some words together and it was not clearly expressing what the idea is supposed to be. You could just look at what was said and take it to refer to just one inertial frame and not several inertial frames. But he's presumably wanting it to mean that all inertial frames are obeying that property. So what he said was a mess. He carries on. Even Einstein's contemporaries familiar with Maxwell's electromagnetic theory of light did not expect the speed of light to depend on the speed of the source. And the text is admitting out to say who the contemporaries were. And I suspect not everyone held that opinion at that time when Einstein was writing things. So it's another mess being made here. He carries on, he says, and they had empirical evidence for this axiom in their pseudo-inertial terrestrial frame of reference. And he never mentioned the term pseudo-inertial before previously, and he doesn't explain what that's supposed to mean. His habit of relativity text to keep coming up with new terms and not properly explain what they're supposed to mean. It's another tactic of obfuscation and these texts have. What I think pseudo-inertial terrestrial frame of reference means is that treating the Earth as an inertial frame, even though it's not really an inertial frame because it has some acceleration motion and is not solely constant velocity frame. Thus, the Earth is a pseudo inertial frame, have to make compensations and experiments for its non-constant velocity motion. But he's not saying any of that. So I'm trying to interpret what he's saying, And I'm thinking that's probably what he means, but how can you be actually sure? Because he didn't say it. He's just making a mess of what he's saying again. He's not making it clear what he really means. So he says, in particular, the direction independence has been very accurately tested by the Michelson-Morley experiment. And the question is, what text is he referring to when he says the Michelson-Morley experiment as support for the second axiom of light speed c? And whatever text it is, it's a lie. And I've got to introduce now what somebody else says. And the relevant person is this one. It's the Professor John Norton. And his paper is this one, the Einstein's investigations of Galilean covariant electrodynamics prior to 1905. And so Norton says in there, even today, this point needs emphasis. The Michelson-Morley experiment is fully compatible with emission theory of light that contradicts the light postulate. So what we have is the light speed postulate or axiom or whatever. It's you don't have to follow it. The Michelson-Morley experiment doesn't show that doesn't show that postulate, but people like Mendler is going to want to assume that it does, so they're just stating a lie. Whether he's intentionally lying or whether he's deceived himself or whatever it is, he's made a false statement. So don't need the light speed c, a postulate stroke axiom or whatever he's calling it, or assumption, to explain the Michelson-Morley experiment. So Rinder trying to use the Michelson-Morley experiment to justify that postulate axiom stroke assumption or whatever is wrong. He's wrong. Or could start going to arguments of Rindler versus Norton saying different things about relativity. So Norton is saying different to Rindler. Rindler is wrong, in my view. Norton is right. And the issue is really underdetermination, and that issue really means that experiments can be interpreted by different theories. And Rindler, like many relativity texts, is going to ignore that and pretend or try to give the impression that relativity, which is special relativity, is the only theory that can account for experiments. So the render text now talks about combining the second axiom with the first axiom. So he says, but when combined with the first axiom, the second leads to the following apparently absurd state of affairs, which we shall call Einstein's law of light propagation. Light signals in vacuum are propagated rectilinearly with the same speed c at all times in all directions in all inertial frames. And of course it raises many problems, and of course those problems won't be answered. And so we've introduced the word law here. And what's the word law supposed to be meant in these in this context? And he's combining two axioms to create a law. What's that supposed to mean? When talking about like speed c, what is that supposed to be relative to? Presumably means relative to some observer, but what observer does the observer have to be in the inertial frame which claims the speed c is relative to, etc., etc. So it's just all a vague statement by him. He carries on, thus if a light signal receives from us and I transfer myself to ever faster moving inertial frames in pursuit of it, I shall not alter the velocity of that light signal relative to me by 1 iota. And he doesn't explain how that's supposed to deduce that from previous statements given. Way back in these anti-relativity lessons, I pointed out relativists like to ignore the how questions. He continues, but it was a mark of Einstein's genius to realise that the concepts were dispensable and could be replaced by others. And there's no reference given by him for where Einstein says that certain concepts are dispensable and could be replaced by others. If you read in Einstein's paper on special relativity in 1905, he doesn't seem to say anything like that. It is just another typical tactic of relativists that they seem to make stuff up. In this particular case, it sounds like Rindler is placing his personal interpretation onto what Einstein is saying, but avoiding quoting what Einstein actually said. Rindler continues, the final form of those others is due to the mathematician Minkowski and consists in a certain blend of space and time into a four-dimensional space-time, as we shall see in due course. So I'm going to pass on commenting on that because it's supposed to be dealt with later. It continues, a first logical consequence of Einstein's two axioms was the elimination of the ether concept from physics. So he's saying he's making a logical consequence, and of course he's not going to explain the logic of that in any way. So how does that consequence arise from what he's previously said? I'm not going to say. So I'm going to have to break down the following what he says into smaller chunks. He starts off by saying each inertial frame now has the properties, blah 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 blah. So it's taking the first sentence. He says each inertial frame now has the properties with which the ether frame has been credited. And so my comment is that it just sounds like he's going to rename ether frame as an inertial frame. And he continues, and so it makes no sense to single out one inertial frame arbitrarily and call it the ether frame. That makes no sense. I've just renamed ether frame as an inertial frame, and since there are lots of inertial frames, there are now lots of ether frames. And so he's talking about single out one, but already have lots of them, not just one. So what's he talking about? It's just totally ambiguous. Arinder continues, it is true that Lorentzi's theory, gentler to the classical prejudices than Einstein's, and observation equivalent to it, kept the ether idea alive a few years longer. But soon Einstein's far more elegant and powerful ideas prevailed, and Lorentzi's theory, together with the ether concept, fell into oblivion. So the point being made here by me is, doesn't explain enough detail. Doesn't explain how, and as noted earlier, relativity texts usually omit answering how questions, so just more nonsense. Mendeleev then gets on to say, finally, in spite of its historical and practical importance, we must de-emphasize the logical role of the law of light propagation as a pillar of special relativity, whatever that's supposed to mean. So dealing with edition 2, which has to be slightly amended from what is said in edition 1, it's saying, as we shall see in section 7x, a second axiom is needed only to determine the value of an invariant velocity c that occurs naturally in the theory, but this could come from any number of branches of physics. We need only to think of the energy formula E equals mc squared, or de Broglie's velocity relation uv equals c squared. Special relativity would exist even if light and electromagnetism were somehow eliminated from nature. It is primarily a new theory of space and time, only secondarily a theory of the physics in that new space and time, with no preferred relation to any one branch. So it's very unclear what any of that's supposed to mean. But he's really making claims which will be dealt with later, so have to defer on most of that until then. But there are a couple of points that can be made. So this is what edition 1 says instead of what's in edition 2. So the thing to note is edition 1 talks of a section 7IX, while edition 2 talks of a section 7X. So in the revised edition they've added an extra section. So he's realised what he's talking about here doesn't really make that much sense, and he's added more. So going through the difference between what is said in edition 2 from what is said in edition 1, edition 2 says only to determine the value of an invariant velocity c that occurs naturally in the theory, whereas edition 1 says needed only to determine the value of a constant c of the dimensions of a velocity that occurs naturally in the theory. Whatever difference, if any, is supposed to be between invariant velocity c and value of a constant c of dimensions of velocity they're supposed to be is not explained. So carrying on, the rest remains unchanged in edition 1 and 2, whatever that means, because I've already pointed out that whatever it means is obscure. Yeah, and so that's the end of this lesson, and we have to continue on in a further lesson to pick up from where we left off here. But you get the general idea. They just don't seem to be talking any sense in these relativity textbooks.